The polyvinyl chloride polymer starts with this monomer that is not symmetrical. And the result is these three different arrangements. And at the molecular level, you can see the differences, and how this plays out at the macro level is that this can lead to the same polyvinyl chloride polymer having different functions, just as polyethylene, pretty different functions from being branched or straight chain. Well, having these different arrangements allows for different strengths of the PVC. So polyvinyl chloride is already the strongest of the big six polymers, and examples you'll see in everyday life. This is in if you have a raft with all these different parts, like a hard helmet and the oars, all of this is PVC. Cables, the most common is pipes. I have an example here. This is PVC pipes are used in plumbing. This has replaced what used to be used for plumbing, which was metal pipes like lead, which leads to the lead breaking down and going into the water. So plastic does break down, but not as easily as metal, which can corrode and rust. This is a version of PVC that is more flexible. So this is a variation of polyvinyl chloride. I have some flexible tape. This is actually not regular tape. This is electrician's tape. It's very, very similar to having this flexible material in medical tubing, and also roofs that are tensile, that's flexible as well. But this is flexible because after the polymer is made, a softener is added. So it's still very strong. I can't easily tear this tape, and yet it's flexible, okay? And that's because this is after the polymer is formed, a softener is added to the polymer. So there's flooring and there's windows. This can be used as building material, and this is the strongest, most durable of the big six. One thing that is not usually known is that PVC, being one of the big six, is a thermoplastic, so it's entirely recyclable. So how many times have you taken a pipe or this type of packaging, or any of this like stuff that you have around the house? It's a very hard plastic, and just thrown it in the garbage. Well, we know that you can put it in recycling. Polystyrene is another example where the polymer can be changed after the formation and end up with two different functions. So starting with the monomer, this is the monomer that has that 6-carbon ring with 3 double bonds. It's called a benzene ring. And when the polymer forms, the double bond in between the 2 carbons becomes a single bond, allowing for bonding on either side. Everything else is still the same. You still have 3 hydrogens and that benzene ring. So what forms is called the polystyrene polymer, and this was from the monomer that's called styrene. This styrene monomer is not symmetrical, so this has all the same possibilities for the arrangements, being head to tail, or head to head, tail to tail, or random. This is showing a random arrangement, so assigning the red as the head and the blue as the tail, and the blue is pretty noticeable because you can see that benzene ring. So this is going to be a head to head arrangement, and then this next is the tail to head, and this is a tail to tail, and now this is a tail to head. And so this is random. It's not head to tail, not head to head, tail to tail. Different functions though for polystyrene are mainly these two types, which are the crystal version compared to the expanded version. The crystal version and the what's called the expanded version, which is styrofoam, these are both very brittle plastics. So I have 2 examples here. This is a styrofoam cup, and this is the crystal polystyrene. So these are both polystyrene, and they look pretty different. So this is clear, and this is opaque. They're both very brittle, so I can take this and crush it. I can take this and crush it too. What they have in common is they're both made out of polystyrene polymer, and this one that is the clear plastic, which is used to replace glass, is crystalline. This is another example, or these containers that are very clear and look like glass. You could even use it to replace glass in like a picture frame or glass windows. Polystyrene, that's the styrofoam version, this cup, has had air blown into it. This contains this polystyrene monomer, but then has about 90% air added. And so that's why this is very lightweight, because it's basically just air, 90%. And so this is a foam that's created and then hardened. So it's called the expanded version of polystyrene, or styrofoam. So you've seen styrofoam as the packing peanuts, or this cup, or this is considered a lightweight and also insulating material because of the air that's blown into it. This cup, it's good for insulating hot or cold liquids inside of the cup, and the reason is because it's basically having a jacket of air around whatever you have inside of the styrofoam container. It's also useful for packing things because the air can handle any kind of crushing or pressure. So styrofoam is the expanded version of polystyrene, and it's about 90% air. You can remove the air and end up with the original starting material, which is just the polystyrene polymer. Version is these packing peanuts, but the crystalline version is something like this, very clear plastic used to replace glass. Cups, this styrofoam cup and this very clear polystyrene cup, they are the exact same polymer. So this is just the expanded form, and this is just the crystalline form without the air blown in. So what these cups have in common also is that they're both recyclable. So this is polystyrene plastic number 6. And how often have you taken a styrofoam cup and thrown it in the garbage, not realizing that it's recyclable? Or these packing peanuts. These are, in theory, recyclable.